Good to see you all coming out. I am Miki Rezentes, and this is my daughter, Kate Rezentes. We will be presenting everything you need to know about security. Now, this talk was originally given a few years back, a couple conferences, and they asked me to bring it back because it was really well received the first time I did it. But when I first came up with the talk, I realized I couldn't possibly share everything that people needed to know about security. And even saying most is kind of a stretch. So this is going to be a tiny bit about security. It's going to be the main things that you'll need to know and be aware of in order to operate as a developer in the world. A little bit about myself. I have 5 kids. Until roughly 9.5 years ago, I was a homemaker, homeschool mom. This is my family. The one with the basketball is this one. So this was a while ago. And then this is a picture that I like of my family. This is a picture that she likes of us. And since we're a team, I have to show it. But you never like yourself in pictures, but as a team, we have to do this again. Yeah, so when we talk about security and how much is known about it, really, something's wrong. There we go, a big empty screen, that's what I want. So this screen represents all the sum of all the knowledge about security that exists, period. The blue dot represents what we actually know about security in total in the industry. The red dot may be what the most advanced security person in the industry knows. But in reality, how this really works out is that it's really hard to know everything you need to know about security because there is so much to know, and how much we actually know about security isn't very much. And so in order to protect yourself from the many risks that are always showing up, you need to follow basic best practices all the time. Now, we worked really hard to take some footage that you're going to see very soon in a couple slides, so just be watching out for it. In reality versus the movies. What happens here in the movies is that you always end up with a display with some amazing graphics on it that are somehow just come up specifically for the problem with no developer time. That's real. Also, people create GUI interfaces in the movies using Visual Basic to track a killer's IP address. That's real. I often hang from ceilings when I'm hacking. It's my favorite position to be in, is just suspended. Also, there's always some type of growing infection graph, and that's always like right for the particular problem and no developer time. All these things are very real because these big visualizations don't actually require development time. And of course, we know that's ridiculous. Everything requires development time, and what happens in the movies isn't very true to life. This is the footage I was talking about. This is my daughter and I working on security. We are so good that we can use the same keyboard at one time. But in reality, this is what security looks like. In real life, and in movies, they try and make it look like you're a superhero. They try and make it look like you're doing all these fancy things. In reality, you're sitting at a desk and most likely installing updates. Because at the end of the day, updates are the #1 thing to protect you from security problems. So this talk is broken down into 3 sections. The first section is personal security, and this is something that everyone in your life can use, from your grandma down to your 3-year-old. Now, if your 3-year-old is needing this type of work because they're spending that much time on the screen, we should probably talk afterwards, because it's too much time for a 3-year-old. But then we'll go into development security, and then we'll go into data security and encryption. In personal security, these are the areas that I'm going to go over. We're going to discuss passwords, logging out, installing updates, not trusting email, and 2-factor auth. And I'm going to go through it kind of quickly because a lot of developers are very familiar with these things. So in the realm of passwords, we have this concept called entropy. And entropy is basically how much randomness there is in a system. The more randomness, the harder it is to guess or brute force anything. So you want your system to have a lot of randomness. So when people think about making passwords, they often think about making passwords that are hard for them to remember or complex for them to think about, instead of thinking about it like a computer. When we look at the top one, which is how many people made their passwords for a long time, they make something like Troubadour 83 and they just shove different symbols in for whatever. This seems hard to us, but seeing as it's only roughly 11 characters, it's not hard for a computer. Whereas correct horse battery stable, that's very hard for a computer to guess. It has much more entropy in it, much more randomness. So when you have a choice between using all the different characters or having a long password, always go for the long password. It usually introduces more entropy unless you're functioning on a restricted character set. But in general, most passwords accept letters, numbers, special characters, and all that stuff. Another thing to remember about passwords is not to reuse them. You want to think of passwords like these items. They'd be gross to reuse them, and you should think about password reuse the same way. Because it's the easiest way to pwn, especially teenagers or kids, is to create a free photo sharing site. And they sign up with their email and the password they always use. And now you can just take that email and password and put it in any site. And most likely they're using the same one everywhere. So in the end, entropy doesn't matter as much because people are actually reusing their passwords. And it becomes, you get one, you get them all. So don't reuse the passwords. If you have reused passwords, or even if you haven't, there's a chance that your data has been breached somewhere at some time. Mine was breached in 2012 in a LinkedIn breach. And so if you go to the site, have I been pwned? You can put in your email address and you can figure out what security breaches that email address was included in. Now, at the time, I wasn't following my own advice because at the time I was not working in security. And so I had used the same password in a couple places. And it was the same one for LinkedIn. And so whoever got a hold of my name and password, they immediately went to AT&T and bought an iPhone. So this is just how it works. Generally speaking, it's not like this brute force hacking. You're not getting like attacked, tied up, or your finger cut off for biometrics. It's just basic hacking and people reusing passwords. So if you're in security or in development, if your organization is not having you use a password manager, that's kind of a big red flag, because password managers allow you to have unique passwords across all sites, and you only have to remember one to get into the password manager. And what this means is the biggest hurdles to having separate passwords are taken care of because the password manager is handling the generation and storage and recall of those passwords for you. And if you can convince your parents or anyone in your family to use a password manager, the great thing is you can share vaults. So for people that have aging parents or maybe have family members that need help with their finances or whatever, having shared vaults where you can share credentials if necessary for access for family members can be really helpful as well, especially if your parents are getting older, because it keeps the password secure without necessarily opening it up to the world. If worst case scenario, this is better than using your same password everywhere. In order to get a hold of your passwords in the situation you actually wrote them down in a book, someone would have to either breach your person or your house or somehow get a hold of it, which is it's much harder to do than just some blasted brute force attack that people often do to try and hack your accounts. So just to review on passwords, don't reuse passwords. You want to make strong passwords. Use a password manager. That was the last point. I made it sound like there was another one, but there's not, sorry. So you guys are a really quiet crowd. I don't know if it's the masks or what it is, but it's really like, so far, we're gonna have to pick up the energy level for you to compete with past crowds. Oh, you're smart, okay, good, because it's just like, everyone's just got this poker face with mask on and I totally wanna be safe, but it's really hard as a speaker because I'm looking out and thinking, I'm boring the crap out of these people. But it's okay, because the material sometimes can be boring. That's all right. All right, so logging out. This isn't always logging out of a browser. This can be simply locking your phone as well, because it'd be ridiculous to say you have to log out of all your apps all the time. People aren't going to do that. But making sure you lock your devices, and it seems like such a simple thing to do, but we are 100% sure it doesn't happen. And the reason why is I don't know if your Slack ever has like a general channel where people put things in like, I don't know what happened, but I seem to have lost my pants. That's usually not them. Usually they left their computer open and someone got on their computer. It's great fun for the people that get on the computer. It's less fun if you're the one that is apparently broadcasting that you lost your pants, which actually is a running gag at someone. Yeah, Genesis, they're a development firm. So anyway, we were at a conference last week in Austin at ElixirConf. We spoke together there as well. And because Texas didn't have mask mandates, it's like, you can see people's faces. It's a very different experience, I'm gonna say, as a speaker, having everyone masked. Enough with myself. All right, so another critical thing that I'm gonna continue to remind you of all through this presentation is you need to install your updates, because everyone thinks security is flashy. In reality, it's bumping versions. That's most of security right there. Because in most security breaches, what you find is that the breach was completely preventable, and the software patch has been available for months, but people didn't put it in. We see this with different types of ransomware exploiting holes, which could have been patched. or maybe you're on an old browser that's not patched. There's all kinds of reasons to bump versions, but keeping your browser and your operating system up to speed, up to current version, is the most important way for you to protect yourself against these type of breaches. Also, email. We wonder, like, it's been years since that famous Nigerian prince started email. So we're like, do people really still fall for this? Well, it only takes one to encourage them to do it more. So I have a joke, I can't tell it because I'll upset people. I always joke that this guy's the manager. I'm not against management, but anyway, you know, someone's gonna click on that. He is the, well, is he? I don't follow it enough to know, but he is the manager. That's great. Okay, so it's not quite as edgy as I thought. All right, so email is not secure communication. It wasn't designed for security, and it can contain a lot of nasty stuff. And I think many people that click on emails, they do it out of this weird sense of reciprocity. Like, we have an obligation to open the email. This person is my friend. I'm not expecting this attachment, but they would never send me anything bad. And we do it because, I don't know, we tell ourselves all kinds of stories when we're doing things that are stupid. But don't be afraid to look at, to throw away email without looking at it. And if maybe you're thinking, okay, maybe this person is reaching out to me, proactively reach out to them on some other network. Figure out if they're sending it to you. Because the number of secrets for like espionage type secrets that are stole through this method is really high. Like, an entire company that was manufacturing turbines was breached through a phishing email, and like China just sifted all of their intellectual property, just bam, gone. You know, it's very easy. It takes one click. So email is excessively dangerous. Don't open it, don't click it unless you're expecting it. The other thing you can do on a personal level to protect yourself is two-factor auth. Two-factor auth is when a company is expecting you to complete 2 forms of identification prior to authenticating you. How this works out is it's something you know, something you have, something you are, or where you are. So the most common type of two-factor auth that's kind of hidden from users, and banks use this a lot, would be when they do the password thing, but silently, without telling their users, they're doing the geographic location thing. So that if all of a sudden you're signing in from a new location or from a new device, they know that something's different and you need to make sure that you are who you are. So sometimes two-factor auth is wrapped in for stuff for you by companies not pushing it down to the customer. But whenever you have the option to turn it on, you should. And the most common way of using it is the password is something you know, and then the phone or your email or your YubiKey is something you have. So in this situation, what I have on the slide are the 2 most common forms of two-factor auth, which would either be an app on your phone, which is much preferred to SMS messaging, because there are plenty of stories of someone's Bitcoin wallet getting hacked because what they did is they called the phone provider. Now this is the way around SMS, by the way. AT&T and other providers offer you the option to give them like a passcode, some special thing, not just your password, some other information in order to change the account. They're doing it for this reason, that someone had SMS text messaging as their Bitcoin 2FA. And someone called the provider, I don't know what provider it was, switched the number of that person over to their phone by claiming their account because they had enough information to do that, tried to get into the Bitcoin because they had the password, then was able to do the 2FA, and by the person figured out what was gone, what had happened, their money was gone. So she didn't know that. She hadn't heard this story before. But so it's very common for SMS to be hackable, so I try not to use SMS wherever I can. In fact, I had to file a complaint recently with Amazon. They won't let me remove my phone number from my account. They insist on it being one of the factors. It irritates the crap out of me. Like, take my phone number off my account. I don't want you having that information. And there's no way to get it. Poor customer service. I try and be nice because they're working their butts off, you know, but it's not their fault that Amazon will not allow me to move my phone number, but they don't need that information. Anyway, so two-factor auth is basically you're going to use your password, then you're going to validate some way, and then you're going to be successfully authenticated. When you configure two-factor auth, you will have a screen of recovery codes. This screen is meant for when maybe your auth app got deleted, or you lost your phone, or you don't have your YubiKey for whatever reason. These codes are extremely sensitive and should be stored along with your password in your password manager. So oftentimes I just copy them, open up my 1Password, and put them in the notes section. And that way, when I'm away from the internet and I cannot maybe get a code or something, or maybe I don't have my phone, I have a reusable, I have a one-time use code in my password manager that I can get into my account with. And then just remember, if you don't delete it, here we go again. Not that I don't love being on the big screen. It's very slimming, by the way, in case you've not been on the big screen. It's very slimming. Makes yourself feel very good about yourself. Anyway, I know, me and pictures. Okay, so recovery codes, you're gonna wanna save those someplace safe. And a lot of people are gonna blow by that screen because they're like, what does this matter? But if you ever lose your authentication app, you're gonna end up in this weird cycle with customer service trying to prove you are who you say you are. So that covers all of password, personal security. Now we're gonna go on to development security. And all you fellas in the room, I am trying to do my part to make conference bathroom lines equal. Okay, because they're always ridiculously long for the guys and really short for the women, which is really good for me. So I am trying to pull more women in the industry. This is my daughter, she's gonna go over development security.
Well, that's a great way to put it in a customer complaint to Amazon. Maybe they'll fix that now. Okay, I'm sorry. Okay, yeah, that is tripping me up. Okay, development security. There's always that one person. What we mean by that one person is always unconsciously breaking your software. They're taking 1,000 characters and pasting them into a 15-character text field. So we can't trust user input. Right here's a list of some, but not all the things that should be going through our head as we're developing code and developing code. Yeah, I just said the same thing twice. The next thing would be obscurity is not security. What that means is just because there's not documentation for whatever you're using doesn't mean someone can come in and break it. Can't. Did I say can? Okay. They can come in and break it. They can figure it out. Front-end validation is just a pre-check. You know, if I start yelling, it's because I have 4 siblings. So just plug your ears or just give me a sign. Just gonna give me this sign. Front-end validation is just a pre-check. So just because you check your code in the back end, you also need to make sure it's checked in, well, you check it in the front end, make sure you check it in the back end as well. If your API isn't protected, nothing is protected. Ask yourself if your dependencies are up to date, if you understand your permission models, and if you understand everything your app is dependent on. A great resource for knowing what the vulnerabilities are that you need to protect yourself against is OWASP. They have this list called the OWASP Top 10. This is actually what I did my senior capstone on. This is the top 10 from 2013. This is the top 10 from 2017. What you'll see is the red here is what's also in the list from 2013. So for the past decade, the same vulnerabilities have been the top vulnerabilities. You want to learn how to defend against these. Know what the vulnerabilities are, research how to defend against them, make it hard for people to break into your system. Next up is framework security. So this includes Rails, Phoenix, Node, things like that. A great way to keep your security and your framework up to date. Here's an example. Node, this is for a Node developer. You can sign up for emails and they'll send you emails every time they find a new vulnerability in the framework and you can fix that. It's kind of a really advanced technique, but I think you can figure it out. Next is language security. This would involve version bumping or best coding practices that you'd also have to research yourself with whatever language you're working on. If you're wondering what the security vulnerabilities are for a thing, this might be difficult, but what you can do is you can Google what are the vulnerabilities for that thing. Last thing I'm going to cover is readable code. Making sure your code is readable is important because you and your team need to be able to go over it and identify vulnerabilities really fast. That's difficult if your code isn't easily readable.
Okay, so the next portion of this is monitoring. And The use case that I learned the most about monitoring was when I was working for a place called Spreedly in Durham. I created an iframe solution to collect credit card information. It's all PCI sensitive data. But there was always the risk of someone, it's a very slow hack. You can't do it very well over lots and lots of credit cards, but you can do it effectively, a man in the middle on that, by presenting your own UI to collect those things and then proxying that through to Spreedly. And that would be a hard thing for us to block from happening on a browser, because the way the headers are configured can make sure certain protections are in place, but we actually can't stop some of those manually heavy breaches. Instead of being able to protect against it, we had to be able to detect when it was happening. And so what you're dealing with there is trying to make sure that, for example, someone's putting in a credit card and they're generating a token with that credit card. Basically what Spreedly did was take the very sensitive information, store it, and then would hand back a token that would identify that card to the merchant. This would allow the merchant to make sales and make charges through Spreedly by using that token and never having to pick up the PCI compliance of having that data on their servers. But it is possible to kind of hack through that. It's very heavy, but you could do it. And so how we defended against that was with monitoring. Because with monitoring, we could tell maybe one computer was making a ridiculous amount of requests for tokens of different credit card numbers. And that monitoring would let us know first, it would let us know what's normal, because we're gonna have a lot of normal interaction to know, like, how many times does someone really do this? Do they ever do it with multiple cards? And so you can get a threshold of how often is this the case with monitoring. You can identify irregularities. If all of a sudden someone is making 15, 20, 30 cards from the same IP address, you gotta wonder, I mean, is that for real, or is this just someone hacking and doing like a very heavy man-in-the-middle attack? Another thing is you have to automate alerts, because no matter how great your metrics are, and no matter how great you are detecting those things, if you're not actually raising that to the level where someone can see it, it's completely useless. So a lot of times people will put parts in place, but they don't run the whole thing. It's kind of like when people back up a database and they never test actually restoring the database. You know, if you're going to have metrics and you don't have alerting on it, what are you doing? And then the other thing it helps you do is gather forensic data to either catch the culprit or prevent it in the future, to figure out exactly what had happened so that you can prevent it.
For development security, make sure you install your updates, and you're working on a team, and it takes one person to create a hole with whatever you're working on, which leaves the team vulnerable. So making sure everybody is up to date and everybody is doing their part is very important.
So this is the bulk of the talk right here, is data security and encryption. So when we talk about data security and encryption, inevitably the new kid on the block comes in and they're like, I can fix this. Like, there are so many problems. I know what to do. I know how to fix this. And then 6 months later, they land in the same place, or worse, they ship something and they don't know what they're doing. Rolling your own security is extremely hard, and I advise against it. It's one of the reasons I don't get down into the details of different types of algorithms, because we really shouldn't be doing this on our own. People spend entire careers working on this, and good for them and good for us for using that research. Because there are possible weaknesses in all security and encryption. Sometimes it's in the algorithm itself. Sometimes that algorithm looks great and then someone figures out there's something wrong with that algorithm. Other times the algorithm is perfectly fine, but how it gets implemented in different ways gets borked. And so you need to be aware that you don't want to take on any of those risks yourself. There are too many amazing people working on this problem to try and do it yourself. Your section reminder that you need to install your updates. Okay, so what does encryption, data security really mean? Well, it comes down to two parts that I'm going to focus on. There are other parts, but the parts I'm going to focus on for today are protecting data confidentiality, which means making sure people that aren't supposed to see things don't, and making sure people that are supposed to see things can. And then also preventing file tampering, because I think file tampering is one of those things that a lot of people overlook. It's why people install things without verifying checksums. They don't understand why the checksum is valuable, why we should be checking it, and what kind of information the checksum gives us. So first I'm going to go over confidentiality. This gets down into encryption, because, and the very first place we start with this, that everyone needs to know this, is that you generate keys when you're going to encrypt something, where most of us are very familiar with public key encryption. And in that type of key generation, you end up with two keys, the private key and the public key. The public key can be shared with anyone, and you're totally safe to do that. The private key cannot. If you share your private key, not only can someone read things that are supposed to be confidential, they could impersonate you. Don't ever, ever share your private key. It's always the best one to mess up, by the way, is flipping private out for public during this part of the talk. Anyway, so how encryption works is you start out with some kind of plain text, and you use a key in an encryption algorithm to generate a ciphertext. And then you use some key and encryption algorithm to decrypt that to get the plain text back. So the process itself is fine. When some types of encryptions, the key to encrypt and decrypt is the same. Other types, it's different. So when we talk about using the same key, both the sender and the receiver have the same key. That's called symmetric key encryption. And when you have a public-private key pair for each person, that's asymmetric key encryption, because now the keys that are being used are not the same on both sides. Symmetric key is also called private key encryption, and asymmetric key is also called public key encryption. We have a really good example of this, the private key encryption, in A Christmas Story. In A Christmas Story, he writes a way to get little Annie orphan decoder ring. I think that's what that is. Anyway, the message that's generated and put over the radio is generated by using the same Annie orphan key or a copy of it that he has, and then he gets the message and he decodes it. That's like very basic, very simple symmetric key encryption. Public key encryption or asymmetric key encryption is different. In this situation, Bob wants to send a message to Alice. And Alice is allowed to share her public key as widely as she wants because it's completely safe. Bob, using the public key, allows him to encrypt the message and send it to Alice. Alice uses her private key to decrypt the message. And you'll notice in this situation, Alice has distributed her public key, totally fine, and she has her private key. That's the way it's supposed to be. There are lots of encryption algorithms, and you could learn a lot by studying all of them. But for the most part, most places that are going to have you do this type of work, they're going to already have a standard picked. You're not going to have to pick that standard. Federal work versus other work might require different algorithms, but they'll be specific and usually what they want you to use. I don't know how many people have done base 64 encoding, but you'll run into a lot with encryption and stuff. You'll always notice that certificates and stuff usually are in base 64 encoded. And so I want to talk briefly about what that is. One, because I'm a math nerd, and I actually like this kind of stuff. It's fun to me, so you just have to sit there. Base 64 encoding is when you're taking a message that might contain many more characters than 64 characters, and you're going to reduce it down into a 64-character alphabet and transmit it that way. Now, the reason why you're doing this is because there are lots of different characters out there, and by standardizing standardizing the 64 most common characters, you can guarantee that most programs or anything that's going to touch that encoded data have the characters necessary to handle it. Whereas if you had some kind of weird obscure character in there, it could make it difficult if someone doesn't have that character in their set of data. So you're going to pick 64 characters that are most common. Generally speaking, this is going to be uppercase A to uppercase Z, lowercase, and 1 through 0 through 9, and then also the plus and slash. When you're base 64 encoding, it's really cool that base 64 is 2 to the 6th. And so you're basically taking it from 8 bits down to 6 bits. So you put it into its 8-bit representation, stack them all together, take it in chunks of 6, and see what it turns into. And that's why when you do base 64 encoding, you always end up with that same small character set. Now we're going to go into preventing tampering. And I think a lot of developers skimp on this because they don't always do their checksum check before they install stuff, and that's a huge risk. Because checksums are a small piece of data that guarantee the file has not been corrupted. And how it guarantees the file has not been corrupted is that it uses hashing. So when you hash something, in this situation we have Fox, we have these 3 things in the blue or teal, and basically they go through the hash function, and what it outputs is a specific hash that every time you put that Fox in, it should get the same exact hash out. Now imagine you're downloading a file, and before they distributed the file, they calculated the hash, and maybe it turned out to be the very top hash for Fox, right? Well, if you go and you hash that file on your own through the same function, and it doesn't match, most likely someone has injected malicious code into that file, or malicious something in there. And the fact that the hash is off is the clue that something's wrong. It doesn't tell you what's wrong, it just tells you what you have isn't what you think you have. So making sure you're checking your checksums and your hashes is important for making sure that data is not being tampered with or files aren't being tampered with across the wire. A cryptographic hash is slightly more in depth than a hash in that it's usually a hash technically could be reversible, but cryptographic hashes aren't reversible, and we should be using them to store passwords. If anyone is doing their own password management with their app, you need to make sure that you're not storing passwords in clear text, which as obvious as that seems to many of us, a ton of people still do. You should be hashing it prior to putting it in the database, and then hashing whatever the user puts in and comparing the two hashes. If the hashes match, the value is the same, and at the same time, you have no idea what the initial value was. So it protects the intellectual property of the user, which is the password, and it protects to make sure that the password is what it's supposed to be in order to gain access. Cryptographic hashes, the diagram looks very similar. It's just that the key and the hashing algorithm are a little bit more rigid and rigorous than you would find just in a normal hash. Good hash functions are deterministic, meaning that whenever you put a single piece of data in, you get the same exact hash out on the other side. They should be quick because you're going to use them a lot. They should not be reversible, and they should have low collision because you wouldn't want red dog being put through the hash and blue dog getting put through the hash and producing the same hash. That would not be great. So you want to make sure they're low collision. Most of this stuff is abstracted away from us now, and we shouldn't have to do it. If you are doing this type of work, I would start to wonder if you should be. Like, is there a library or is there a service that you can be using? Because keeping up on security is tough, and outsourcing that to a library or someone that has a lot of time and effort to invest in patches is a good idea. MACs are common. You'll see them a lot of times. They're message authentication codes. They're kind of like a symmetric key signature in the sense that a MAC is generated using a key, and then that the MAC guarantees that you know that the key that was used to create the MAC. And you also can say that the MAC also shows, it's a hash that shows the file hasn't been tampered with. So MACs show when file tampering has happened. Signatures are way more common, and the reason why they're way more common, even though they're very much like a MAC, is because not only do they ensure authentication and ensure integrity, they also give you the property of non-repudiation, meaning you can only sign something with a private key, and once you've signed it, that's your key. No one else should have that key. There are some countries in the world where if your private key gets breached, you are liable for someone impersonating you. You have to actually report the fact that your key has been breached. So just remember, signatures, the big value you get by signing something versus using a MAC or a checksum or something like that that's kind of generating it from a generic key that everyone has access to, is that this has non-repudiation. When someone signs it, you know it's from them. To verify a signature, so let's say my daughter Kate sends me something and I want to make sure it's from her, I need to have the person's public key. So Alice here wants to send a message to Bob, and she wants to make sure it does not get tampered with. So what she does is she signs it with her private key. And then that signature is added to the message and it's given to Bob. Bob takes that verification and he runs it with the public key to make sure that this actually came from Alice. And so he can actually prove, Alice sent me this. This is Alice's public key. This verifies that this is who she says she is. So this message is not only accurate, but it is from Alice. So when you think about MACs versus signatures, the big difference is that the non-repudiation that signatures give you, also they're more secure. Oftentimes MACs are generated with keys that are available to many people, not just one. And a super high level process of generating a MAC or a signature is you take a key, you take a signing algorithm that takes a message and the key and produces a signature or a MAC. And then the recipient takes that and verifies the MAC. How this looks, by the way, the diagrams on Wikipedia are shockingly clear. I've looked at a lot of diagrams, and a lot of times when I'm looking at encryption stuff, you'll see them other places and you go on Wikipedia and they've got some decent diagrams that do a good job of explaining the concept. For a MAC or what we have here, this would also hold pretty much true for a signature, but you have a message, you run it through a MAC algorithm, you get a MAC. You send the message in the MAC over to the receiver, and the receiver takes the message and does the same thing again. They create their own MAC and they compare it to your MAC. And if they don't match, then someone's tampered with the file in transit. And so you need to, that would tell you that now you need to get back with that person, make sure you get the correct data. The term HMAC, you'll see this sometimes when you're dealing with different things. This is basically just a very secure MAC because they're using a cryptographic hash algorithm, and they're using a hash function, and they're using a secret cryptographic key. So it's more secure. It's not exactly a signature because you don't have the non-repudiation, but it is more secure than just a MAC. Certificate chains, I think most developers, if you ask them, you know, when you get that screen, you go someplace and it says, wait a minute, are you sure you want to be here? I think a lot of people understand why that's happening, but they don't actually know why that's happening. Usually what that's telling you is like, we see this website, we don't recognize their certificate. This doesn't make sense. Are you sure you want to go there? Because if they don't have the certificate that's associated with the website, then going there, you might be doing a man-in-the-middle attack, or it might just be not even trying to man in the middle. Maybe they're just trying to scam you of data. You don't know. So certificate chains are what protect you against that. Basically, there are certificate authorities. They are a trusted third party, and they have these root certificates that they use, and they also generate certificates for companies. So they'll issue different digital certificates to different companies. And then the certificate, they certify the ownership of different public keys for the company. So for example, let's say IBM has a website, which I'm sure they do, and your browser goes to connect to that website. The website sends down their public key to you. That's the very common step, is they're going to send that down. Now, the root certs that ship with your browser are going to test to make that certificate is from who they say it is. That's why you want to update your browsers. If you don't update your browsers, and maybe a certificate has been revoked somewhere or something like that, you might not get that update, and you might be susceptible to a man-in-the-middle attack. So the browsers store the root certs, and whenever a server responds with a certificate, the browser knows to check it to make sure it is the right thing. How this works is the end entity certificate, so let's go with the upper left-hand side on this one. Let's say that's IBM's certificate. Well, they most likely have an intermediate certificate between that certificate and the root cert. And so what happens is the subject, so if we think about these as children and parent, the child has a subject, which is the owner's name, and then it has an issuer, which is that issuer's name, right? Well, the issuer matches the subject of the one before it. And that issuer matches the subject of the one before it, all the way down. And you can actually verify all the certs all the way through to make sure that they have actually signed each other. And then as long as that root cert is good, then you know you're good to go. No one wants to deal with that kind of headache though. It's all wrapped up in the browser, and the browser ships with those certs. So make sure when those Chrome updates come out, you want to make sure you update them. It can save you from a lot of pain. X509 is a common type of security format for certificates. It's a standard. You'll see this used for all kinds of stuff whenever you're trying to make connections with, like, verify authentication between servers. Like, we were doing work with MasterCard at one point, and we had to connect with their servers, and so we had to list the different 509s on both sides so that we would be able to connect. It's a standard that's used. So if you see X509, that's a standard security cert. And then, yeah, so this still follows the same idea of the chain. This is basically the same thing as that graphic that I showed before. I leave it in the slides in case someone wants to go back over the slides later and see the thing and read the description, but I already gave the description, so moving on. Now, many of us have been asked in an interview how a browser makes a connection with a server. And we're going to go over that next, because understanding how the handshake works can be helpful, just very helpful knowledge across the board when you're developing web apps. So high-level connection steps. First, browsers are shipped with a collection of root certs, which is the main reason you want to update them all the time. Then you want, the client sends a hello to a server, some server somewhere. And it also sends what cipher suites it can use. Most people think that when we connect a browser to a server, well, it just connects and it does the secure thing. But there's more than one. And sometimes different pieces in the chain won't support one ciphertext or other. So like maybe the server supports only the most recent ciphertext. And then the browser maybe it's old, maybe it doesn't support all the recent ones. It wouldn't be able to make a connection. So normally what happens is servers will support all the new stuff, plus some of the old things. So what happens is these cipher suites that are used to protect the data between the server and the browser, if you don't update your software, you will keep cipher suites in use that are actually have been breached or are known as problematic. So updating your software ensures that you're only using the best cipher suites to connect. So the client says hello. Then the server says hello. And then the server sends down its public cert. And the client normally sends up their cert as well, depending on protocol. Then the client creates a secret, and that secret it shares with the server. And it looks like this. I don't know how many people have studied Diffie-Hellman. I only do like high level because I don't encourage people to get down in the weeds on encryption. It makes them feel very powerful, and then they want to do things, and I highly recommend against that. So basically, in this situation, Alice and Bob have that yellow colored paint, and that is the common secret between them, and they can give that to each other without a problem. Then Alice mixes her secret portion with it. Bob mixes his secret portion with it. They trade. Then they mix their secret portions in again, and bam, they end up with the same common secret. This is very much the picture of how a client and server create a shared key so that they can start symmetric encryption. Symmetric encryption is much faster than public key encryption. And so you want to get to that as quick as you can. And so this is what browsers and servers are doing. They're coming to the fact where they have a shared key so they can symmetrically talk. So to go on with the steps, so the server and client, they each generate their keys. Then the client says, okay, I'm ready to switch over from asymmetric to symmetric. And the server says, yep. And then bam, now all messages are encrypted symmetrically between them. It kind of looks like this too. I think this is another good picture for it because you can see that Alice has Bob's public key, which she mixes her private key with, and they combine keys and end up with a shared secret. Bob does the same thing. It shows that they have some kind of shared secret between them, but like they never let go of their private key. They never give that to anyone else. A blockchain is a whole thing. And this is blockchain. If you're wanting to get into blockchain, when I was studying this, I think the hashing part of it is the most interesting part because these blocks are built by hashing all the things together. And then of course, that's why it creates this ledger that you can't change, is because if you were to change any piece of it, then the hash would change and you would know that there was something wrong with the block. So and blockchain is here, and I've never actually been able to get to it in a talk because of the fact that I've always run over. So blockchain is an interesting technology, and it's fun to study. It will not solve all your security problems. So it's not good. It's always part of the thing thrown in there. But there is something that's really fun to do, and that's to go to GeekTyper. Does anyone know, has anyone seen GeekTyper before? Okay, so when my kids were younger, like think about the picture I showed at the beginning with my little tiny kids. Now imagine taking them to a coffee shop and setting up this and letting them do it until the alarm goes off, and then quietly closing everything up and walking out. It's great fun. Let me get to it real fast. Here we go. This is GeekTyper, and this would be fun for your kids too, right? So how this works, this is a website, and I've chose the Aperture one. This is just a prank. There's nothing real happening. But whenever you type, when I start typing, you can see I'm typing all kinds of stuff. It's so much fun. And let's say I'm going to do things now. Like, so people in the coffee shop are now starting to wonder what's going on, because normally when I press 0, an alarm goes off, but it's not working right now because of my computer. But you have all this stuff going on. It's great fun. And then you just close it all up and walk out. But only after you need to do it on your own and push the 0 key, because then the alarm goes off. It's very jolting. But it's a great fun way to, kids love it because they feel like they're typing a bunch of stuff like a hacker. Adults love it because it's just funny. But there's a bunch of them, like a bunch of movie theme ones for this site. So anyway, that's all I have for you today on data security and encryption. I would take questions. I don't think we're really set up for it, but feel free to catch me afterwards. I'll be here for just a little bit. And that's it.